For the mainline design in TURBOdesign Pre, we start by selecting the machine type, which is radial inflow turbine in this case. And then the next section is the specs tab, and here we select the rotor, vane nozzle, and volute components since we are interested in designing the full stage. And then the design point specifications, which is the expansion ratio, rotational speed, and the mass flow rate, which are generally part of the specs. And the working fluid in this case is ideal gas, and we also specify its conditions at the inlet. And then we have this Cordia diagram here, which immediately shows that this design sits in the high efficiency region, and so the given specs can lead to a high performance radial turbine. The next section is stage composition, where we specify some more details about the different components. So starting with the rotor, we need to specify the outlet hub diameter and also the outlet absolute flow angle, which is 0 because we want a purely axial flow coming out of the rotor. It's also possible to specify either the inlet diameter directly, or it can be calculated from the velocity ratio or jet speed ratio as it is called. And the rotor can be designed for maximum efficiency or for minimum rotor outlet shroud Mach number. And then some optional parameters to impose various dimensions and the number of blades. Now for the nozzle, we can go with the default settings, or we can also set some parameters and the number of nozzle vanes. And then for the volute, we can go with the default elliptic asymmetric section, which is commonly seen in radial turbines, the fast linear calculation method, and a sizing parameter of 1 for perfect conservation of angular momentum. And we don't need to change much in the convergence parameters, and then we can run the calculation. And in less than a second, we have the flow path along with some basic dimensions and estimates of efficiency, and the RBT star, which is like the work coefficient for the different components along the stage. And as we scroll down the report, we have some more details on the individual components, such as the pressures and the velocity triangles as well. And do make sure that this particular setting is selected, as this will automatically export the parameterized meridional flow path for all the stage components from TD Pre all the way to multi-point and multi-objective design optimization in TURBOdesign 1. And then finally, with this button here, we can save all the files, which will later be used for the 3D inverse design of the rotor and the nozzle vane in TURBOdesign 1. And then we also have these performance curves available, such as the mass flow rate against the rotational speed. So this is the design point, and you also get some idea of the off-design performance at other speeds and also at other expansion ratios. And then finally, we have the efficiency and the power curves as well. And with that information, we can then proceed to the 3D design of the turbine stage.